Hi everyone, we are covering differential equations today, and we've been dealing with differential equations for a little while. They're given in a form similar to this, where you have the derivative in terms of x and y, and generally we want to solve for y, which is our original equation. Right, so this is what's called a separable differential equation, and we solve these by doing separation of variables. What we mean by that is I want to get one of each kind of variable on each side of the equal sign. So I want to get my y and my dy on one side, my x and my dx on the other side. So I can do that by multiplying both sides by y, and then multiplying both sides by dx. So first step, okay, so I just canceled y out. Now I want to get this dx to the other side of the equal sign. So these will cancel. I have y dy equals 2x dx. Okay, so now I'm in good shape. I have a variable and it's, I guess, differential in this case. So I can take the integral and each variable is accounted for. Right, so the integral of y is going to be 1/2 y squared. The integral of 2x is going to be x squared. And then because it's indefinite, we have to put a plus c. All right, now we just want to get y by itself, so I can multiply both sides by 2. And remember, anything that we do to c, it just absorbs it. So we don't really have to write any coefficients or anything. I can just write c. Okay, and then we just need to get rid of that squared. So I'll put a plus or minus square root, 2x squared plus c, and I've gotten y by itself. So I solved for y as a function of x. All right, this is called the general solution, again, because I have a plus c in it. So sometimes we're given an initial condition. All right, so this means that at 1, or like when x equals 1, y equals -3. So what I can do with that information is plug it into my general equation. Okay, so that means -3 is equal to plus or minus square root 2 times 1 squared plus c. So all I did was I plugged in -3 and I plugged in 1. Right, this is the coordinate that it gave me. X is 1, y is -3. So I just plugged those values in, and now I can solve for c, just like we did, with our general integrals. Okay, so I can square both sides. This is just going to be 2. I get c to be 7, and so that means that my particular solution, my particular solution is going to be plus or minus square root of 2x squared plus 7, because I solved for c. Right, so this is my particular solution because I do not have a c. I solved for c using my initial condition. All right, let's do another example. This time it's written a little different, and then they went ahead and gave us our initial condition right here. Okay, so I can rewrite this as dy dx, just because that makes it a little bit more obvious to me what we're doing. All right, so I'm going to bring the dx to this side by multiplying. I'm going to divide both sides by the square root of y to get y on this side. Right, what that's going to give me is, well, we can write it out. Right, and another way of writing this would be y to the -1/2. Okay, now I can integrate both sides. All right, so I have my y's and my y's, my x's, my x's. All right, so I'll get 2y to the 1/2 equals 1/3 x cubed plus c. Okay, and so this is where you can kind of do what you need to solve the problem. Depending on where you plug in your initial condition, you will get a different value for c, but you will get the same answer in the end, always. And so personally, I usually like to plug in the initial condition right here. And so let's just give that a shot. Let's go ahead and solve for c. All right, so I'm going to plug in 4 for y and 3 for x. Right, and so if I solve for c, I end up getting -5. Okay, this c is specific to this step in the problem. Right, so this c being -5, I have to plug that in to this step. Okay, so what I mean is, if you solved for c to this step, and then you kind of went ahead in the problem and you simplified it some more, you couldn't use this value for c. Your c value would change, because remember, whatever you do to c, it just absorbs it, right? And so whatever specific step you stop and plug the initial condition in, that's where you will have to plug, well, that's the step where you have to plug that value of c that you solve for. Okay, so right here, I found that c was -5, so I plug in my value for c at this step. Right, now I can continue to simplify some more. So I'll divide everything by 2. Right, and then I can square both sides. Okay, and so this is my particular solution because I have no c's. Okay, I solved for everything. Hey, now you could solve for c in a different step than I did. I usually like to do it right here because it's a lot easier to plug the initial condition into this step, but you could have simplified it all the way to the end and gotten your general solution and then plugged it in there, and you would have gotten the same answer. Okay, you would have gotten c to be whatever. But you would have gotten the same answer in the end. Okay, the only thing that matters is that you plug in whatever value of c that you find, you plug that into that particular step. Okay, but we can go over that more in class if you have questions. All right, and one more example here of a separable. Okay, so here again, I just need to separate my variables, so we're practicing. I have y to the -2nd power, and then 4x dx. All right, so I can take the integral of both sides. And so I get -y to the -1 equals 2x squared plus c. Okay, now again, I'm going to solve for c at this step. Okay, so I'm going to plug in my coordinate here. So that means that I'm plugging 3 in for y, and I'm plugging 1 in for x. Okay, that means that c is -7/3. Okay, so again, I'm plugging whatever value I get for c, I'm plugging that into the particular step in which I plugged in my initial condition. Okay, I simplify a little bit. All right, and then I simplify a lot bit. So I'll take the inverse of both sides. And this is my particular solution. Okay, let's go over some vocabulary. Alright, so that you'll be able to set up some word problems. So if I say that y is directly proportional to t, okay, that means that y equals kt, where k is called the constant of proportionality. Okay, so k is some factor, okay, it's some constant. T and y are both variables. Okay, so k is always going to be a number that we can solve for, and we will do that later, but not right now. Okay, but y and t are our dependent and independent variables, respectively. Okay, inverse proportionality just means that y would be k over t. Right, so in this case, we have the inverse of t, 1 over t, but still times the constant of proportionality. Joint proportionality just means that k is still there. It is proportional to both of these at the same time, essentially. So we're just multiplying everything together. Okay, that's all that means. You don't see this very often. You honestly don't see this all that often. You will see this quite often. Okay, direct proportionality is very common. So let's just practice writing a couple steps out, and then, I don't know, maybe we'll solve something. All right, so first, it just says that a certain population increases at a rate proportional to time t. Okay, what this means is that the rate is directly proportional to my time. Okay, so the rate at which a population increases, that's going to be how my population changes over time. Okay, so dp dt is directly proportional. So my constant proportionality goes there, and I just multiply it with my variable. Okay, a certain population increases at a rate proportional to the square root of the population. Right, so again, it's a rate of my population. So it's my population changing over time. is directly proportional to the square root of the population. Square root of the population, that's it. All right, a little more. The population is increasing at a rate directly proportional to 800 minus P of t. Okay, a rate again, so it's going to be dp dt, right? So this is my rate, is directly proportional to 800 minus P of t. All right, this is very common. We'll see this a lot. We'll practice with this a lot. All right, last one. A population y increases at a rate inversely proportional this time. Okay, so this time it's dy dt. Okay, my population is y, changing with respect to time, is inversely proportional to 250 minus y. You could also write this as k divided by 250 minus y. Either way works, right? So this is just the inverse. Okay, that was kind of long, but that's it for these notes. See you later.